Welcome to our Java programming tutorial. Today, we'll learn how to create a minimap, a fun and interesting feature that can enhance any game or application. A minimap provides a small glance of the larger game world, making navigation easier for users. Let's dive right into it. Before we begin coding, let's outline what we are going to cover in this tutorial. We will first set up a basic Java project using a development environment. Then we will implement the minimap feature using Java's GUI capabilities with the Swing library. By the end, you will have a simple minimap integrated into your Java application. Let's start by setting up our development environment. If you haven't already, make sure you have JDK installed on your machine. You can download the latest version from the Oracle website. After that, download and install an IDE like IntelliJ IDEA or Eclipse. Once you have your IDE set up, create a new Java project. To start building our minimap, we first need to create a main class. Inside your newly created project, create a new Java class named MinimapDemo. This will be the entry point for our application. Now, let's set up a basic GUI window where our minimap will reside. We'll use JFrame to create our main application window and set its layout. Here's how to initialize the JFrame. Next, we'll enhance our window by adding a JPanel where the minimap will be painted. This can be achieved by subclassing JPanel to draw our minimap. Let's call this class MinimapPanel. Now, we need to instantiate MinimapPanel in our MinimapDemo class and add it to the JFrame. Let's proceed with that. Now that we have the basic setup, let's start drawing our minimap. We'll first define the dimensions of the minimap and then draw a simple representation of the main world. Inside the Paint Component method of MinimapPanel, we will call the graphics object to draw rectangles to simulate the main map. Let's take a moment to run our application to see the minimap visualized. If everything is set up correctly, you should see a window pop up with a rectangular minimap. The blue area simulates the game world while the black border surrounds the minimap. Next, we will make our minimap dynamic. This means allowing it to represent the player's position on the map. For this, we need to create a small representation of the player character. Next, we'll modify the MinimapPanel class to include an instance of the player class and represent the player's position on the minimap. For simplicity, let's initialize the player's position in the center of the minimap. Let's run our application again. You should now see a red square representing the player's position on the minimap. Although it is static right now, the position will be updated as we add controls next. To make the minimap more interactive, let's add keyboard controls to move the player. We can capture key events by implementing the key listener interface in our minimap panel. With this setup, when you press the arrow keys, the player's position on the minimap will update dynamically. Each key press will move the player character in the respective direction, and you should see the red dot move around the blue area on the minimap. Now we should also consider to ensure that the player doesn't move outside the bounds of the minimap. Let's add boundary checks in our keyPressed method. Let's test this change by trying to move the player around again. The player should now be constrained within the boundaries of the minimap. This prevents unwanted behaviors and keeps the gameplay intuitive. While we have created a functional minimap, it lacks many features that can enhance gameplay, like zooming functionalities. Let's take it a step further and introduce a zoom feature to our minimap. To control the zoom level, we can add a couple of keyboard shortcuts, like using the plus key to zoom in and the dash key to zoom out. Let's implement that in our keyPressed method. We have now implemented basic zoom functionality. Try running your application again and use the plus or dash keys to zoom in and out. Notice how the minimap scales while retaining the player's relative position. At this point, we've successfully created a functional minimap, incorporated player movement, added boundary checks, and even implemented zoom functionalities. As you can see, with just a few lines of code and the right approach, we can enhance user experience significantly. To wrap this tutorial up, you can expand upon the minimap further. Consider adding features such as markers for locations, dynamic tiles for different terrains, or even a minimap that integrates with a full game engine. Thank you for watching. If you enjoyed this tutorial, or if you learned something new today, please subscribe for more Java programming videos. Leave a comment below if you encountered any issues or if you have any suggestions for future tutorials. Happy coding!